This week we'll learn how to upload generated plots from our Python code directly into Amazon's S3 storage service so that we can store them for later or share them with others. Welcome to another MetPy Monday. Hello, my name's John Lehman, a software engineer for Unidata. This week I thought we would go a little bit different route and talk about how we can use Amazon Web Services S3 storage service and upload things directly from Python. And I've done this multiple times when I'm making some maps or producing a derived data set and want to either share it or store it not on my system, maybe because it's too large or because I'm going to access it from somewhere else later. Now, before we go too far, I want to remind you that Amazon Web Services is a paid service through Amazon. You can sign up for a new account and you get many requests to things like S3 or Lambda for free. But ultimately, they do have your credit card information, and you could very conceivably write something like an infinite loop that uploads infinite files to S3 and could result in some charges to your credit card. So it's always good to set billing rules, and Amazon has a lot of tutorials on how to do that, or to just pay very close attention to exactly what's happening so you don't end up with some credit card charges from using the service. With that disclaimer out of the way, once you've created your Amazon account, you can log into the Amazon console and go up to Services and S3. And Amazon does change this relatively often, so it may not look exactly the same, but it will look very similar for you. And then we're going to click the Create Bucket button. Now, bucket names have to be globally unique, so not just to you, but to anyone else in the world. So for example, if I type in test, it's probably not going to be a good choice. But I can type in something like MetPy Monday, and I probably am going to be safe because I don't think anybody's going to have that bucket. And you choose a region. I'm going to put this in the US East region. And then there are lots of options like keeping all versions of an object if you're using this for backups, logging requests, tagging, which helps you track things for billing, and a lot of other options. But for our test, we're going to leave those as defaults. Under permissions, I'm going to go ahead and leave block all public access. So nobody else except me logged in is going to be able to upload or download or even see that there are objects in this bucket. This is definitely the safest. If you do open the bucket up to public access, you need to make sure that you're following some of the best practices outlined by Amazon for security. Because ultimately, unless you make this what's called a requester pays bucket, you will be paying for the bandwidth for somebody to download. So somebody could go and download all the objects in your bucket as fast as they could over and over again and rack up a substantial bill for you. And then it asks you to review the settings, and we'll just click Create Bucket. Okay, now that our bucket is created, we can see it right here, the MetPy Monday bucket. It tells us the access, the region, and when we created it. If I click on the bucket, we go into a page where we can upload or create folders, and we can manage properties, permissions, and so on. So now let's switch over to a notebook, create some plots, and upload them to this bucket without having to go in and click the upload button and do it manually. As always, we're going to start off with a block of imports. I'm going to import NumPy as MP, import matplotlib.pyplot as PLT so we can make some demo plots. I'm going to import a new library, which is called Boto3, which is what we're going to use to interface with Amazon. And then from pathlib, I'm going to import the path object. Now we're going to define, and I'm going to define them globally here, a couple of access things that we're going to need for our bucket. So we're going to need an access key. We're going to need a secret key. And we're going to need a bucket name. Now, generally you would not store these as plain text in your code, especially if you're going to upload that to GitHub. Somebody could get your credentials, so that's something to be careful of. There are lots of ways that you can store credentials and safely access them. For now, we'll leave those as empty strings and come back and fill them in a few moments. Now I need to write a function to make a line plot, and then a function to upload all of the figures to S3. So let's start with the line plot function. This is something that we know how to do. So def make line plot, and it's going to take an argument for a slope and an argument for an intercept. And this is going to be just a real simple plot. We could obviously make a more complicated map or a plot of real data, but the point here is to learn how to upload things to S3, so we're going to keep this as simple as possible. So I'm going to make x range from -100 to 100. Since it's a line, we only need 2 points. Then we're going to use NumPy polyval, which takes the coefficients, so slope and intercept, and the x values, and it will calculate the y values for us. Now you could, of course, go ahead and just type out the formula, y equals mx plus b. It's up to you, but I like to use the built-in functions where I can because this would eventually allow us to use higher order polynomials. Now I'm going to make a plot. I'm going to use CLF to make sure that my plot is always cleared. It's a clear figure before we start. I'm going to plot x and y, turn on the grid, and I'm going to set the y limit to be -1000 to 1000 for our plot. And then we're going to call plot.savefig. And I'm going to save them in a subdirectory that I've already created called plots. So I'm going to wrap that in the path object. And then remember, with pathlib, we can just use the division sign as a path separator. And then I'm going to use an f string to create our name, plot underscore slope underscore intercept dot png. So that is going to store a file with the name plot underscore whatever the numerical value of slope is, underscore whatever the numerical value of intercept is, .png in the plots directory. All right, so there's our code to make a line plot. So let's go ahead and test it out. I'm going to make a list of tuples here that contain the slopes and intercepts for lines that I want to plot. So I want to plot 1, 0, 10, 5, 50, 10, and 2.5, 6.7, just to show that it works with floats as well. So for coef in plots, we're going to call our make line plot function. So make line plot, and it's going to take coef. But remember, coef is a tuple of two things, and our line plot function takes the slope and intercept as separate arguments. I'm just going to use the star syntax and unpack those so that the first element of our tuple will get passed as slope and the second as intercept. So if we run that, we see the last plot that is produced shows up here in our notebook. And now we have those 4 plots in our plots subdirectory. Next week, we'll pick up right here and write some code to upload to Amazon, create an identity access profile so that we can have permissions to upload to a bucket and get these figures uploaded to the cloud. I hope that you found this useful, and I'll see you on next week's MetPy Monday.